Hey guys, today we are starting our first set of notes for Pre-Algebra, which is 1.1, all about integers and operations. So today is going to be just a kind of a tutorial, not only about the notes, but we're going to kind of break down how we are going to be taking notes, because this obviously is a very new format for you, unless you've had a flipped classroom before where you're taking notes on your own and then working on the actual material in person. But pretty much the way that this is going to go, and I have our notes set up as guided notes. So they're going to be just stuff that you have to pre-fill in or refill in. I've got a lot of the stuff already set up for us. It's just going to be any kind of problems that we'll do. You'll go through and record what the answers are as we're going through them together. There'll be some definitions that you have to write down, but a lot of the information is already on the page for you. You're just kind of filling it in as we do together. So anything that I write in here, I'm always going to use a colored ink. So anything that's written down in black is already going to be on your page. Anything in color is going to be stuff that you have to also record, whether it's pencil or you can use different colors to knock your socks off. Okay. I also, you can see the way that I have my guided notes set up for pre-algebra. I have little descriptors of some main ideas or questions off to the left side, that left column, and then the different information will be on the right side. Sometimes it's just examples, sometimes there's directions for our examples, but you can see again the summary or the kind of the topic that we're talking about is on the left side, and then the corresponding definition, example, problem, whatever is on the right side. So, talking about integers. What are integers? Well, integers are whole numbers, which the whole numbers are 0, 1, 2, 3, so on and so forth. So integers are made up of those and their opposites. So integers could be positive numbers, they could be negative numbers, or they could be 0. But they're whole numbers. There's no fractions, there's no decimals to them. It's just a single digit, or I guess as soon as you hit double digits, but you get the idea. On our number line, if we're talking about a line, this is a continuum of all of the integers. 0 would be in our middle, and it flows from positive to the right, negative to the left. So in this case, let's see, 8, 9, 7, 6, 5, 4, 3, 2, 1. So if 0 is here, as we increase to the right, our numbers are increasing in value. So 0, 1, 2, 3, 4, 5, 6, 7, 8. As we move to the left of 0, our numbers are decreasing in value, so that's where our negatives are going to live. You also could look at this as just a reflection of the positive integers, because this would be one space away from 0, so -1, 2 spaces away, -2, -3, and so on and so forth. So -5, -6, -7, and -8. So that's what our number line looks like. It's infinite. That's why we have the arrows at the end. It continues going on in both directions. We can have as big of a positive number as we want to. We can have as big of a small of a negative number as we want to as well. When we're writing integers, this is going to seem pretty easy because it's just copying down whatever the number was. But here you have to pay attention, since integers could be positive or negative. We want to focus on what the situation is telling us, whether that number should represent a positive number because we're increasing, or whether it's a negative number because we're decreasing or in debt. So looking at number 1, a 3-yard gain. Well, that's pretty easy. Gain, that means we're increasing. So this should be a positive 3 is the integer that represents a 3-yard gain. 8 degrees below normal. So kind of picking up on those keywords. Below tells us less than, below 0. So -8 would be that integer. And we'll kind of go through the rest of these. A $75 deposit. So again, maybe you have a bank account, maybe not. If you deposit money into an account, you are gaining value. So that should be a positive 75. 21-pound loss. Again, that one's pretty easy. If you're losing weight, you have negative weight. You're taking weight away from your body mass. So -21. 5 miles above sea level for number 5. Since we are above, that would be a positive. Number 6, $40 deduction. So again, a deduction is something you're taking away. So it would be a negative $40, negative 40 for my integer if we're representing that. 2 strokes under par. Again, you can see that word under, same thing as below. It's less than what the expectation is. So negative 2 in this case for 2 strokes under par. That's a golf thing. And then a $15 surcharge. Surcharge means that you have extra money. So 15, positive 15. So those are just writing out integers from a little description. For our next section, we're going to be working on comparing and ordering the integers. So we know, or hopefully we should know, that positive numbers are bigger than than negative numbers. And then again, looking at it in terms of if we're dealing with 2 positives or 2 negatives, if we're trying to order them in terms of which one is greater than the other, you could also look at this in terms of the number line. The number that's greater is going to be further to the right. So if we're talking about 2 positives, the number that's further to the right is the bigger number, so that would be that one would be greater than. If you have 2 negative numbers, the number that's further to the right, which actually means closer to 0, the smaller digit is the greater number because it's farther to the right. So let's just go through some of these quickly. Negative 12 and 5, that one's pretty easy. Positive is always going to be greater than a negative, so that one should be set up that way. So greater than, it always, again, it opens up to the bigger one. For number 10, negative 7 and negative 23, this one, 2 negatives, so actually the one that's further to the right is the smaller digit. So negative 7 is closer to 0, it's further to the right than negative 23 is, so negative 7 is actually the greater number in that case. Moving along, number 11, positive 1 and negative 6. That's another easy one. The positive number is always going to be the greater one if it's positive versus negative. For number 12, negative 18 and negative 15. That one, they're pretty close, but negative 15 is closer to 0 on the number line. So that one should be greater than. For these last ones, I'm just going to go through just to make sure you can check them. 20 and negative 25. Well, the positive is definitely the bigger one. 14 is tricky because 0 is not really positive, it's not really negative, it's neutral. But 0 is definitely further to the right on the number line than the negative number. So my inequality should be going that way. 15, 36, negative 36 is closer to 0 than negative 40 is. And then the very last one, 16, negative 28, because it's closer to 0 the number line, it is further to the right, which means it is the greater number. So for this next one, we're not going to do all 4 of these together. I'm going to kind of pick and choose some problems. Otherwise, we'll be here forever. For 17, 18, 19, and 20, we are asked to order each set of integers from least to greatest. So what we would be doing then is basically looking at which is the furthest to the left and then continuing to the right. So if you're doing it from least to greatest, you're basically putting it in number line order. Which one would I see on the number line first on the left side, and then my greatest one is going to be furthest to the right. So I would start with your negative numbers. You're going to be like the smallest numbers, the least valuable numbers, are the biggest negatives. So in the case of number 17, I have 4, 0, negative 9, positive 2, negative 5, negative 1, and positive 13. So my least number, my lowest number here is negative 9. Negative 9 is my biggest negative, which means it's my lowest number, my furthest to the left. So, and you can do this, you can do little annotations. I usually like to cross stuff out when I'm working through a list and putting it in order. So my next smallest number would be negative 5. That's my next biggest negative. Negative 1 is my last negative number. And now it just becomes putting them in order from smallest number to biggest number, since the rest are all non-negative. They're all positive. So 0, 2, 4, and 13. 0, 2, 4, and 13. Yep, we've used all of them. That is in least to greatest order. So I am good there with number 17. Let's do 19, I guess. or you can do 20 and you want to check your work, go ahead and do that. But number 19, again, I'm going to start with let's do number 20. 20 looks a little bit scary, doesn't it? So in this case, maybe another strategy you could do, if you want to start with the negatives, you can always underline all of your negative numbers so that's easier to see which ones you're dealing with, since we're going to be putting it in least to greatest order. So I'm looking for that biggest negative number. That would be my furthest to the left on the number line. So in this case, negative 65 is my first one. I've used that. My next one would be negative 52, negative 33, and negative 31. Those are my 4 negatives. So now I just order my positive numbers in the order I would usually put them in. So since we're trying to go least to greatest, positive 37, and then positive 48. For 18 and 19, if you wanted to try those two, I'll put them in least to greatest order real quick. So negative 27, negative 24, negative 11, negative 8, 16, 21. And then over here, negative 18, negative 10, negative 4, 9, 12, 15. So you can go ahead and check number 18 and 19 if you wanted to try those on your own. If you felt pretty good about 17 and 20 that we did together, all good as well. All right, our next idea here is an absolute value. Now, you've probably looked at absolute value and you have a basic understanding of absolute value. Most people look at it and just say, oh, the absolute value just makes any of the numbers positive, which is true, but the definition of what an absolute value is, it is the distance from 0 on a number line. So if you remember, as I was talking about the number line up above, we said negative 2 was 2 spaces away from 0 on the number line. We're just 2 spaces to the left. That's the basic idea of what an absolute value is. The absolute value, which we use the 2 upright bars, the 2 vertical bars to represent the absolute value of x in this case. That's just telling me I want to know whatever the distance is from 0 of the number inside these 2 bars. So if my number is 7 inside the bars, 7 is obviously 7 units away from 0 on the number line, so the absolute value of 7 is 7. If I had the absolute value of a negative number, negative 20 is 20 units away from 0 on the number line. If I was starting at negative 20, I would have to count 20 spaces to get up to 0 on the number line. So while in practice, it does kind of just make everything positive, and we're just looking at the actual number of things, the definition of it is a little bit different. It's the distance away from 0 on the number line. So the absolute value of negative 4 is positive 4, because that's 4 units away. 24, absolute value of 18 is still 18. When the numbers are positive, they don't change. When the numbers are negative, they just flip signs. So for the last ones there, absolute value of 18 is 18, the absolute value of 35 is 35, and the absolute value of negative 11 is just positive 11. All right, flipping on over to page 2. Now we're getting into kind of the second idea here, which is all about operations. So operations meaning addition, subtraction, multiplication, division. Those are different types of operations. Throughout your high school career, we'll spend a lot of time on a bunch of different types of operations that you probably haven't even heard of yet, but we're starting with the basic ones to make sure that we have a solid foundation and we can build upon that. So if we are adding integers, if you are adding, that means we are moving to the right on the number line. So you can think of it that way. Whatever that first number is, that's our starting point on the number line. If we're adding value to that, it's just telling us how many spaces to the right we're moving on the number line. So negative 3 plus 8, if I move 8 spots to the right on the number line, I end up at 5. So that's the kind of the tricky part. If you need a number line, if that's going to help you to visualize what they are added together, you can do that. Positives, I know we're going to be confident with that. 1 plus 8 just being 9. I know the tricky part is going to be when we start adding with negatives. So like number 2, negative 11 plus 9, if I'm negative 11, so 11 spots to the left on the number line, if I move to the right 9 spots, I'm still 2 spots behind 0. And again, maybe that's easier for you if you're looking at a number line. If that is the case and you really benefit from a number line, let us know, let me or Mrs. Smith know, and we can always have a number line printed for you that you have, from negative 15 to 15, so that you can easily kind of go through those and just start counting spots. So for number 3, if you're at negative 2 and you move to the right 6, you are now at positive 4. If you're at negative 7 and you move right 7, you end up at 0. Negative 21, and then to the right 3 leaves you at negative 18. And then if you start at negative 9, move to the right 13 spots, you end up at positive 4. So adding is just moving to the right, if you're looking at it in terms of the number line. Subtraction is just the opposite of that. Subtraction is just moving to the left on the number line. So we're subtracting value, we're deducting value, we're moving to the left. So negative 1 and then 3 spots to the left would end up at negative 4. Again, these are easier for us when they're both positive numbers, if we're subtracting a positive, especially if the first number is bigger than the second. So 9 minus 4 we know is 5 because 4 spots to the left is 5. Negative 2 minus 5 leaves me at negative 7. 4 minus 6 should be negative 2. Negative 3 minus 3, be careful here. This is not the same thing as 3 minus 3 or, negative 7 plus 7. In this case, if you were at negative 3 and you move left 3, you end up at negative 6. Negative 28 minus 8 should be a negative 36. And then negative 5 minus 11 is a negative 16. Be careful, and I know a lot of us are going to get tripped up by this. This might be kind of our kryptonite and things that we're struggling with. Be careful of double signs. So I tend not to write it this way. Sometimes we'll see them with the double signs where it's something either as plus a negative number or minus a negative number, mainly with negatives. What I want you to do, instead of having it as plus a negative, just so we can simplify things a little bit, we're going to just write that as a subtraction. So if we're adding a negative, that's the same thing as subtracting that same number. And if we're subtracting a negative, 2 negatives make a positive. So we're going to write this as addition. So with these ones, I'm going to rewrite them first if we are adding a negative. And then you can always find the sum or the difference. So here, 2 plus negative 6, that's the same thing as saying 2 minus 6, right, if we're adding a negative. So that should be negative 4. Okay, so if we do that with our other ones, you can either, if you are good enough to keep that organized in your brain, knock your socks off. I think most of us, at least while we're getting used to this idea, probably want to show some work. So negative 7 minus 1 gives me negative 8. Negative 20 minus 5 is negative 25. I'm going to bounce. We'll just go down one column so we're not, going overkill here. Negative 15 plus negative 14. Well, that's the same thing as negative 15 minus 14, which is negative 29. Now, when we get into number 19 and beyond, we're subtracting negatives, which again, if we subtract a negative, that's like adding a positive. So this is the same thing as 9 plus 2, which is 11. 0 plus 10, which is 10. And negative 2 plus 23, which is 21. If you want to, I'm just going to put the answers up on the rest of these. If you want to check your answers, go ahead and pause the video real quick and test yourself. But we should have gotten 16, negative 6, negative 9, 13, and 28. All right, last part here. Now, when we're working with absolute values, what I would suggest if you have, we have two different operations that we're going to do, or two different styles of absolute value problems that we'll see. You'll have an absolute value problem where it's two absolute values added together. In that case, just evaluate both absolute values and then do the operation. So in the case of number 25, absolute value of 13 is 13. Absolute value of 15 is 15. So it's the same thing as just saying 13 plus 15, which gives me 28. You also have some problems where the operation, the thing that we're doing, the addition or the subtraction, is inside the absolute value bars, in which case simplify that first. You do not apply the absolute value until it's a single number. So for number 27, absolute value of 21 minus 8, well, I have to do 21 minus 8, which is what? 13. So the absolute value of 13, which is 13. So I have to do that operation first. 29, I'll go back to doing them separately since it's two different absolute values. So this becomes 3 plus 5, which gives me 8. Number 31, negative 7 minus 16. Okay, so I have to subtract. So negative 7 and then move it to the left, 16 should give me a negative 23. But now that it's a single number, I can apply that absolute value. The distance from 0 on the number line of negative 23 is positive 23. And then for my last one, for number 33, I've got a subtracting a negative, which we should remember means we're going to add the opposite. We're making it a positive, making it a plus. So negative 14 plus 1 is a negative 13. Next, moving it to the right one on the number line. So positive 13 should be my solution. Again, if you want to try this next set, the other half on your own, go ahead and pause the video real quick and work through that on your own. My solutions, if you want to check yourself, should have been 38, 7, 5, 0, and 13. Okay. Rules for multiplying and dividing integers. So when we multiply or divide, we know how to do that basic operation if we add if we multiply two numbers together, or if we divide the two of them. Now, with integers specifically, our signs make a big difference because when we added a negative or when we subtracted a negative, those signs may or may not have changed. Our rules for multiplying and dividing are similar to those. If we multiply two positive numbers together, they make a positive. All right, two positives multiplied together, they're positive. Two negatives multiplied together, a negative times a negative actually also makes a positive. It's only when I have a positive times a negative that my answer ends up being negative. So I have to be careful because the multiplication of it, it's going to be remembering your 10 by 10, your multiplication table. If we want, I know a lot of you probably have had that in the past, and me and Mrs. Smith can get one for you. We have a multiplication table if that's going to be beneficial to you, or you can always use your calculator if you want to check yourself. But what we're going to be doing here with these is just multiplying them together and then just double checking to make sure our sign matches. So I use a couple of different ways to write multiplication. You can see I've got 3 different ways written up here. When we're multiplying two numbers together, I could use a small little x to mean multiplication. Negative 9 times negative 3. Well, 9 times 3 is 27. A negative times a negative is a positive. So my answer should be 27. Parentheses also represent multiplication. If you have a number on the outside of a parenthesis, that I'm multiplying those two things together. So here, 8 times negative 9 should be negative 72, because 8 times 9 is 72. I have one negative involved, one positive, which means my answer is going to be negative. For number 39, I have 2 negatives, so my answer is going to be positive. 4 times 7 is 28, so my answer is just positive 28. The last notation we use for multiplication is just the dot notation. That's the one I usually use if I'm typing up the notes or if I'm typing up the quiz or the test or anything like that. I usually will use just the dot notation for multiplication. Still means the same thing. 11 times negative 2 should be a negative 22 because 2 times 11 is 22. I have one negative involved, so my answer is negative. And then number 43 should be negative 45 because 5 times 9 is 45. Again, one negative. If you want to check yourself, do some more example problems here with number 36 through 44, the even ones, go ahead and pause the video, but I'm going to fill in the answers so you can check your work and see if you're correct or not. 44, negative 60, 48, 24, and negative 32. All right, last section, dividing. So same rules. If we're dividing two positives, it's positive. If we're dividing two negatives, it's positive. If we're dividing a negative and a positive, it's negative. So same rule as multiplication. Now it's just working backwards. I have only two ways of writing division, either with the division symbol, like number 45 through 48, or with like the fraction / bar for like number 49 through 54. So dividing 63 by 7 is positive 9. They're both positive. They stay positive. 9 divided by 3 is 3. They're both negative, so then my answer is positive. 90 divided by 10 is 9. They're both positive, so they stay positive. 8 divided by 8 is actually 1. It's a little bit tricky, but 8 divided by 8 is 1. I have the negative there up top, but not below, so my answer should be negative. And then last but not least, 42 divided by 7 is 6. One of them is positive, one of them is negative, so my answer should be negative. Same as before. If you want to check yourself and test yourself to see if you can do these last 5 problems, go ahead and do that. I'm going to go ahead and just fill in my answers to make sure that you did that correctly. If you did not do it correctly and you don't understand why, let us know. We'll walk through it with you. That's it for today, though. That's our notes. If you want to put a little summary, I'm not going to fill that in for you. But if there's things that you want to summarize to make it easier once we're starting to go back through these notes and getting ready for quizzes and tests and reviewing, feel free to go ahead and write a little summary of what you think the most important things were there. The homework that you're going to be working on is a worksheet similar to this. It's just a single page. And I think that's all I got for you. So if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.